Okay, how's everybody doing? We are recording this meeting and it will be posted to our YouTube channel. So our last meeting was held on October 19th, 2022. Roger Harrod with Matthews Bus Sales presented on the proper maintenance and safety that needs to be taken when working on the Thomas electric bus. And he had a lot of good points. It was a good presentation. He went over that the batteries will disconnect when they get low. The coolant runs through the batteries to maintain the optimal temperature of the batteries. Let's admit this person. Just so you know, anybody who just joined the meeting, it is being recorded and will be posted to our YouTube channel. There are 3 levels of certifications, and one is for the drivers and anybody that's just going to be around it. 2 is for the mechanics. 3 is stuff that you have to be certified for. Matthews does that kind of stuff. But I imagine that as we move on with electric buses, we will all be working towards becoming certified, working on them. And that's one of the reasons that we're going through with having Matthews with the Thomas. Bluebird will be next in December. And that way we have all 3 of the manufacturers that we're dealing with, and we'll work towards certifying people. So let's see if we got anything else good on that. The inspection, the charger port should be inspected every year on the Thomas bus. The transmission is used and fluid has to be checked on it. And that was just some of them. But again, that whole meeting was recorded. So if you want to go to our YouTube channel, you can see the full video there. Today's presenter will be Kodie Shamrock with Leonard Bus Sales. He will be presenting on the International Electric Bus. So we'll be turning it over to him. But before we turn the meeting over to him, George Geel with Shenendehowa Central School District wants to say a few words here. Take it away, George.
All right. Ladies, gentlemen, Z's, I's, M's, kitty cats, however we identify. COVID's over, so DEC is back. And we got a DEC inspection the other day. So I just want to give you a quick rundown of what they went over. He wanted to see our daily inventory and reconciliation reports. He wanted to see our weekly tank sticks and water testing, our weekly VLD tests. And then I got to clarify, some of my testing might be different than yours because of the tank setup I have. I have fiberglass reinforced plastic tanks. I have 2 of them that are double wall. 1 that is a 1984 single wall, which is its own little beast that has all kinds of special things. And the 2 double walls have a brine in the middle of the 2 tanks, so that if I have a leak, I get water into the tank from the brine, or I get no brine at all that goes out into the ground. So if I have an external leak on the outside, the brine goes away there and I get an alarm. And if I have a leak on the inner tank, the brine goes into that and it says I'm full of water. So that's how that works. So I have a European suction system. And what that is I have a check valve on the bottom of the dispenser. The pump is in the dispenser and it's suction from the dispenser back to the tank. So it's kind of like having your finger over a straw. So you pump, it pumps. The check valve closes. All the fluid is in that line going back to the tank. If you get a leak in that line or the check valve fails, it's like taking your thumb off the straw and all the water goes back, or this would be fuel, back into the tank. So that saves me some inspections there because I don't have to have a pressurized line. It's a suction line. So I don't have to have pressurized inspections on them lines. So what I had to show them was my daily inventory and reconciliation reports, my weekly tank sticking and my water testing, my weekly VLD test. That is on my single wall tank. What is that? That's a variable leak detection. And what it does every week, it checks to make sure I don't lose more than 0.02 gallons in a 4-hour period. And that's done during 4 hours on Sunday when we're not pumping. I had to have my monthly above ground storage tank inspections. I had to have my monthly underground storage tank inspections. I had to have my monthly spill bucket and under pump containment inspections. I had to have my yearly tank tightness test on my single wall tank. I had to have my yearly functionality test on my tank gauging system. I have to have a triannual spill bucket leak test and overfill protection test, which I didn't have because I was told by my vendors I didn't need that because I was a European suction system, but I do. And it was 4 months overdue. So I got to get that done and show them that. That was one of the defects I had. I had to have my as-built plans on hand to show them. I had to have a site map plan on hand to show them. And I had to have a $1 million proof of liability on hand to show them. I didn't have that. I didn't know I needed that. But when I went and looked, it says you have to have that. That's the first time he's ever asked for that. So if anybody has any questions, they can give me a shout here because I know that's a lot to take in. But don't worry, all the regulations are in that 2,000-page book that they have online. Have fun. But you can get in touch with me, 518-881-0243. I'm willing to help out anybody that needs help. And I'll give it back to you, Dan.
Okay. Well, I think all of our districts are going to be subject to the tank testing and stuff. So, we did just have our inspection and there's a lot of information to take in, but that's what we had to deal with here at Shenendehowa.
Well,
so
on the good note is, in 2035, we won't have to worry about it anymore because we'll be totally electric.
Yeah. Yep. Then we'll have to worry about battery disposals. It'll be something different. But as of now, we're going to turn the meeting over to...
I hear they burn up nice.
That's one way to get rid of them, huh? We're going to turn the meeting over to Mr. Kodie Shamrock, who's going to present on the International Electric Bus. So take it away, Kodie.
All right. Can everybody hear me okay? All right. Excellent. So let me just get this set up here and we'll get rolling. Okay. Assuming you can all see my screen, I can't see you guys. So if you can't, shout. Otherwise, I will keep rolling. So, okay. So the electric bus CE series, really, when it comes down to the safety side of working on an electric bus, whether it's an IC, Thomas, Bluebird, Lion, Green Power, whatever it might be, more or less the safety concepts are the same. Bright orange cables are high voltage, don't touch them. We say that not to mean that you're going to be shocked if you do, but really just don't plan to work with those cables, disconnect those cables, or plan to diagnose anything related to them. So this overview really is very specific to our bus, but really when it comes right down to it, the way we get power to the rear axle is not horribly different bus to bus to bus. There's really only so many ways to do that. Very much like your diesel engines are, Cummins engine is a Cummins engine, regardless of what bus it's in. It's powering the rear axle the same way. So these are more or less very similar to one another. Very first thing I'll start with for you guys is sort of what your job would look like going forward. A lot of people ask, well, what am I going to do now? There's nothing to do. And the answer to that is there's still things you need to do. You're not going to have oil. You're not going to have fuel. You're not, in our case, going to have a transmission, turbo, EGR, all of the usual sort of diesel engine type stuff that we're used to, or gas or propane, whatever you're running. But when you think about what your day-to-day is, most of the time, it's brakes, it's tires, it's, chasing electrical gremlins in the 12-volt system. It's, chassis maintenance. It's sort of the usual sort of preventative type stuff. That doesn't go away. The chassis is the same. The axles are the same. Tires, brakes, body, they're all the same as what we're used to. So all of that PM work that you do doesn't really go away. It just looks a little bit different, and maybe there's a little less of it. So, I like people not to get too hung up on thinking that they're going to be, basically regulated out of a job, because there's still plenty of work to be done. And as I said, a lot of it stays the same. Your kids are still going to tear seats open. Drivers are still going to back into things and break lights and knock mirrors off. And, your brakes are going to have to get done. Your tires are going to wear out. That stuff is all the same. So really take comfort, I think, in that. A lot of us aren't doing warranty engine work at this point. If you've got a Cummins engine that decides that it's had enough, you're not typically the one that's going to be rebuilding it anyway. It's under warranty. It goes back to the dealer. So these systems are very much the same. Whereas if your high voltage system is having difficulties or needs diagnosing, you're going to send that back to the dealer, or we're going to come to you and take care of it. So some of the safety items that you will need, and this again is not a unique to us sort of thing. It's industry standard stuff. You're going to have that fiberglass safety hook. And really with that, the idea is, as a technician is disconnecting the high voltage, you want somebody else there as a backup in case something goes wrong. It's, very unlikely something would, but you always want to be prepared for a worst case scenario. You'll use lockout tag out with these if you're working on the high voltage system. A lot of us have lockout tag out stuff, but it's covered in dust and we don't use it. So we will have to get in the habit of using lockout tag out equipment, using high voltage gloves, having a barrier or boundary around the work area, so that, one person is sort of responsible for maintaining the high voltage system at a time. When it comes to the gloves, right now, none of you really are going to need to worry about buying high voltage gloves. If we get to a point where you're starting to work on the high voltage system, they're a very specific type, and they have to be recertified by an outside lab every 6 months. So we are already underway with that in our facilities. We have a program now where our gloves are being sent out every 6 months to be recertified. And that's whether you use them or not. So as far as shop equipment goes, these are special tooling components that we would use for our bus in particular. You would not need to have this stuff in your shops, at this point. This is not something that you would have to worry about, but we would either bring it to you, or when your bus comes back to us, these are the things we would use to either remove batteries or remove the drive motor, whatever it might be. Most of your tooling and equipment is going to stay the same. You'll still use a multimeter. You'll still use your coolant management tool. As long as it's pressurized, it'll work on this system. Not too much is really all that different. So our bus in particular, we have the option of 2 different size battery packs, which is something that we're happy about at this point. What I would say is that I'm sure all the manufacturers are going to get to a point where there's multiple different options. We're in the early days of this thing, so everybody's still trying to figure out, what's up and what's down. But our standard range is about 135 miles advertised. You're not going to get 135 miles out of it. Realistically, you might get 70, 75, and that's just a guess number. Don't ever expect you're going to get 135 out of it. The 200-mile range is an upgrade. You can buy that third pack, and that will give you probably more like 130, 140 usable miles. So it sort of puts you in line with the standard pack. Again, this is something that's the case right now. It's going to change for everybody as time goes on. They'll get better. Everybody will be able to go farther. But right now, this is what the option is. So the 135-mile pack will work on basically your 65 or 66 passenger bus, or if you have like a 42 passenger body with a wheelchair lift, that's where you're going to see that battery pack. If you want the larger pack, you're going to have to go up to a 70 passenger body, 72 passenger, somewhere in there. And there's a lot of variables to what battery packs work with what configuration, bus weight, all that kind of stuff. So with that, I'll talk about the bus weight in a moment here. We do have 3 levels of regen braking that I'll talk about. We can fast charge or level 2 charge, either way. We are vehicle to grid ready. My personal take is pretend vehicle to grid doesn't exist. And I'll explain that kind of toward the end when I get to the warranty stuff. So we can go, 29 to 72 passengers on these buses. We can, the wheelbases are, somewhat variable depending on, again, configuration of batteries, seating capacities, that kind of thing. One thing I do want to point out is the GVWR. The rated GVW on these is the same as any other bus that's out there right now. We do have people that order a diesel bus with a 33,000 pound rating. What seems to be an area of question that we're still trying to figure out is, though the GVW is the same, and that's your loaded weight, your unladen weight or your empty bus weight seems to be heavier than a diesel or gasoline powered bus. We don't know what that actual weight is. We're trying to figure that out, but that's not an easy number to come by. I point that out because there are certain things that we're used to getting that you might not be able to get depending on how you spec your bus. So, that 33,000 pound rating is the absolute maximum that vehicle can be or will be. And in our case, we may not be able to do laminated glass. We might have to eliminate 3-point seatbelts, at this point with the current axle ratings. So that's not a broad sweeping, requirement, but as these are spec'd out, as you work with your advisor, out here would be Roman or Jose now, was Sean, he's retiring. You're going to see some stuff like that comes up. So don't be too surprised if we have to start reducing weights in other areas. We have standard stability control, which you're used to at this point. I'm actually in Saratoga today, and we have trade buses coming in with collision mitigation on them, which is hard to believe already. So this stuff is out there. Rear axle ratio, not terribly different. We use convection heating. There is an option for air conditioning. We'll see how that looks. We don't know what that's going to do to batteries. You can get a charging port in the front or the rear, depending. It can't be both. There will be a sound generator. So basically 20 miles per hour or less, there will be an audible tone or sound played through an exterior PA. And that is to let people know that the vehicle is on the move. Outside of that, we use a Dana motor, which is pretty common across the industry. And our bus is air disc brake only. So at this point, you cannot get drum brakes on an electric bus. And that's just kind of the way it's going to be going forward, it appears. I don't see that changing. So to ID one of these, it's pretty straightforward. You've got a roof logo that will tell you it's electric. Your badge by the entry door will tell you it's electric. And then possibly you'll have the electric powered sticker on the bumper. That could change depending on, again, if you rhino line your bumpers or not, you're not going to have the sticker, but more or less, you're going to know which buses are electric. So our bus, we can produce a peak of 342 horsepower. The torque on these things is pretty unbelievable, but there's no lag there. It is direct drive. There's plenty of torque in an electric motor, as you know. We will send about 800 volts of power to the drivetrain, basically, to make the bus go. And I'll kind of build on this a little bit more as we go along here. But the important number is horsepower and torque. So obviously, to move these things, charging is definitely the biggest problem that we're being faced with right now across the industry, whether it's school bus, truck, or car. Being able to set up chargers is problematic because you might not have the power that you need to do it. So all that aside, the actual bus itself is really the simplest part of this. Assuming you have chargers, assuming you can plug in, all of that, we have two options. So you can do, let me pull up a little pointer here, just make this a little simpler. We can do AC charging, which is a much slower level 2. It's sort of the cheaper charger or more affordable charger. It's going to go through a charging interface, which is basically a computer that is determining, how much power is coming in and sort of metering that and saying, do we need all of this? Do we not need all of this? And then, delegating accordingly. It'll go through the onboard chargers here, which is basically at this point a conversion to DC. Go into the high voltage distribution unit. I'll show you what these parts are. Into the distribution module, into an S box, and then out to the batteries. So it has to go through a few different places before it gets directly to the battery. If you get into DC charging, this is sort of your high speed, more expensive option, which you will need in some cases. You can sort of bypass these onboard chargers because you don't have to convert that to DC at this point. It's coming in as DC and we don't have to do anything with it. So it seems like at some point AC charging will kind of go away. That is the general chatter that I've heard, and will go only to DC. I don't know if that's true or not. We'll see what happens as time goes on here. So the charging port itself, again, it's all sort of one big unit. You've got a DC cap at the bottom here. You've got your AC on the top. You do have a charger plug release cable in the event that you can't get it to release for some reason. You pull that cable and it will release the charger. So there's also an indicator button here with a light around it that will tell you the status of charge. And I'll show you that here in a little bit as well. So let's see here. So to actually charge one of these things is theoretically very simple as long as the bus drivers can follow instructions. I get that can go very wrong with some people. That's just the nature of the beast. But what you're going to do is set the parking brake. You're going to make sure you're in neutral, so normal bus securement procedure. And you need to have your 12-volt disconnect switch in the on position, which is the one inside the battery box in our case. And then you're going to basically plug the charger in. It's going to take about 20 seconds to figure out, what the system is doing, where it's at, what it needs. And then that charging process will start all on its own. And the indicator light in the charging port will tell you sort of, is it charging? Does it recognize that it's here? And kind of go from there, and you can leave it alone. So if for some reason, you've plugged it in and it's not charging, we kind of go back to the whole, shut it off and try again thing. You would pull that charger out, push it back in. And again, you'll get a light on here that'll illuminate blue, and it'll say, the bus connection is secure and we can begin charging. So while that's happening, it's going to flash. And again, there's different colors. And when we start getting these buses out there, we'll have information, a card that would show you what each color means, so that there's really no guesswork there. I mentioned the onboard charging interface. That's always going to be right near the charger itself, usually right above it. And that, again, is receiving data and taking that information, broadcasting it over the 1939 network. And the bus is sort of making decisions as to how much power it wants to take in, at what speed it's going to take it in, and just basically monitor that system. It's sort of your gatekeeper, if you will. So your charging indicator lights, again, there's a bunch of them around there. You can press the button in the center to release the charger itself. But these indicators will tell you where things are at. So if for some reason, you plug it in and you have a blinking amber light, it's basically telling you that there's an interlock or something is preventing the bus from actually charging. So that might be that the charger cable is not in all the way. Maybe the driver didn't set the parking brake. Maybe they shut it down without putting it to neutral, whatever it might be. That indicates that there could be a problem. So solid amber, again, it's not fully inserted. Flashing green is always a good thing. That's charging in progress. The solid green, I think I probably copied and pasted and never fixed that. So we're going to ignore that one because I can't remember what it means. And then red is fault detected. So they're somewhat intuitive. Red is usually not a good thing. I'm thinking solid green is probably actually that it's fully charged and ready to go. So I just got to fix that. So your gauge cluster on the electric bus is a full LCD display. And if any of you saw the bus at any of the trade shows the last year or two, you've seen what this looks like, and it's a pretty nice setup. basically you've got a few things on here that are going to be different. So you've got a thrust or regen gauge here, and this basically is indicating how much power is going out and how much power is coming back in. So as you are accelerating, you can go up to potentially 100% power, which is not ideal, for battery life or range, but you can go up to 100% power. And then you're going to see a propulsion load here displayed as well. And when you are in a regen braking situation, which I will talk about here soon, you're going to see that needle dip down into the negative, and that's basically power being fed back into the system through the wheels, which are acting as a generator. So again, I'll kind of elaborate on that a little bit later. Your high voltage battery charge or range will be displayed similar to a fuel gauge. You'll see your estimated range remaining. You'll see approximately how much battery life is left. The way our system is designed in most is that empty is not truly empty. Empty is more like 20% state of charge left. And really, it doesn't mean we want to use that last 20%, but there is theoretically still a little bit of wiggle room there that you can work with. It's just sort of a protection because it's not good for the battery to go any lower than 20% state of charge. Air pressure indicators are very similar to what you're used to now. This would display the actual pressure here for primary and secondary. Not too much to say with that. Your high voltage battery temperature, I'll talk about the battery thermal management system, but just like any other bus, we have to be able to control the temperature of the batteries. Like most people, they prefer it to be around 68 to 70 degrees. And this system will tell you roughly what the battery temperature is at that point. Propulsion system. So this is your drive motor, basically indicating the temperature of that. That unit is obviously spinning at a high rate of speed, and it does need to be cooled as well. So regen braking, just kind of to elaborate on that a little bit more. When we say regen braking, we don't actually mean braking. Just like when you say exhaust brake, you're not actually using the brakes to do anything on a like a Cummins engine. In this case, really, it's using that power to slow the vehicle down. So we can adjust our regen braking level 1, 2, or 3, and that's a standard on our bus. The driver can actually tweak how much power or regen they want out of it. One would be, kind of average, suburban area, city street type stuff where it's going to hold you back a little bit, but not a ton. The inverse is level 3, which is basically 1 foot driving. You do not need, or 1 pedal driving. You don't need the brake pedal to bring your bus to a complete stop. So it's powerful enough to bring you down to a stop all on its own without touching the brakes. The nice thing about this is while you're in this regen braking, what's happening is you're not asking for power from the battery at that point. What is happening though is your wheels are spinning, and they are spinning that drive motor. So what we can do is actually flip that power flow and have those wheels that spin act as a generator and feed the power in reverse back into your batteries. So that is a nice option to have, and all the buses have it at this point. And the idea with that is, we can recoup some of the power that we've lost going down the road. Don't expect that you're going to be able to fully recharge your batteries just by slowing down more gracefully. You're never going to get it all back, but you might gain back, a mile here, a mile there. And that does make a difference over time for sure. The only time this won't work is if you are at 100% state of charge and you are, you're leaving the yard first thing in the morning or before the afternoon run, and there's no room left to put charge back in, so that regen braking will not work in that way. So you've got a drive mode indicator, reverse neutral drive, pretty straightforward. Our bus still uses 12-volt batteries. And believe it or not, if those 12-volt batteries are not charged properly, the bus will not start. So with that, the 12-volt batteries are sort of what wakes up the ECM, what wakes up all the electronic components and says, okay, we have to go to work now. If that system is dead, not charged, it's not going to be able to do that. So fairly similar to what we're used to now. Dead batteries don't do us any favors. So some of your gauge cluster indicators would be low charge. here. So sort of a, low fuel light, if you will, coming on, and that's, at 20% or less. That's pretty much an indicator that you need to get back ASAP, or you're going to have a dead battery. We do still have electronic stability control. So if it's active at the moment, it'll flash as it does now. If there's a problem with it, it'll light solid. A lot of this stuff is what we're used to. And I'm not going to read through every single number here, but give you some of the highlights. Traction control, we're used to this light. If we have traction control on, we'll see that light flash as we go down the road. If there's a problem, it's going to be, lit solid. So regen braking, this would indicate that there's a fault somewhere in that regen braking system where it's not able to function properly. And then number 5 here is a drive defect. So there's something wrong with the drive system or charging system, and it needs to be addressed, basically. You have a battery light for your 12-volt batteries that will indicate if the charge is too low or too high. And then, of course, if you have a brake system fault or problem, you're going to have a brake light come on just like you would now. As you get in these buses for the first time and you start to drive, there is a sort of, I guess you can call it a wait to start, but sort of a procedure that you have to follow. When the bus is ready to be driven, you'll see the drive indicator light up in green. So that indicates the bus is ready to go and you can, go about your day. So number 11 here, the wrench with the triangle. We're pretty used to that at this point. We know what that means. You need service at some point in time. And then lastly is the turtle down here, and that indicates that your power is restricted for some reason, whether it be that the batteries are overheating, they're too cold, let's say your thermal management system is not working, and for some reason the batteries are not heating, or you have very low power because you are below 20% state of charge. These are the lights that you would see come on. On the other side, again, a critical fault in the EV system would it be indicated by this red light here. We know that usually any red light is not great. Any yellow light we can sort of deal with when we need to or when we can. And then, of course, we have an ABS light here as well. So a lot of these systems are similar to what we're used to. The lights are similar to what we're used to. There's not much difference there. The only one I didn't point out is this 21 down here showing your power steering system. If there's a problem in the high voltage power steering, that will tell you. So go through some of the components here. Again, there's a lot of information here, and I'm trying to give you the highest level I can without rushing too much. As I said in the beginning, any orange cable is high voltage. If it's orange, don't touch it. I said, if you put your hand on it, you're going to be fine. Just don't start chasing orange cables and trying to figure out where they go and what they do. That's not something at this point that anybody other than a dealer technician would actually do. The cable itself has a core inside of it surrounded by insulation, and there's also a fault detection circuit in there. So this fault detection circuit is exactly what it sounds like. So if you are in a situation where for some reason something penetrates one of these cables in an accident or, with a tool while you're working under the bus doing whatever, that fault detection circuit is going to be broken, and the system will recognize that, hey, we have a problem in our high voltage system and we need to tell the operator now that there's a fault. It is placed outside of the core for a reason so that you hit the fault detection circuit before you hit the part that actually carries the power. There's more insulation, and then, of course, an orange plastic covering that will tell you that it's high voltage. So we use a system of zones, basically zones 1, 2, and 3 for being able to work on these systems. A lot of the high voltage labels are things that we're used to. Nothing really unusual about those. They're pretty straightforward. So we do have, a lot of safety pieces in place. All the manufacturers recognize that you have to protect the cables, you have to protect the operator, you have to protect the person working on it. And for that reason, again, we have a system monitoring the entire electrical system all the time. And if there's a break somewhere or there's a fault somewhere, it's smart enough to be able to tell you, hey, this is a problem, and I think this is where it is, which is something we've gotten used to with fault code diagnostics. We think there's a problem in this part. This is very much the same idea. The high voltage system is completely isolated. It runs independent of itself. Of course, if there's a grounding issue, you're going to be aware of that. It will let you know. And again, we have multiple levels of disconnect, which the idea behind that is we can isolate certain sections of the vehicle so that we can diagnose and still work on things and have some power, but not right where we're working on it. So if you kind of think of like the electrical panel in your house, if you're going to be replacing outlets in your living room, you're going to shut off that circuit. That would be, let's say, shutting off zone 1. You can leave all the other circuits on. It's not going to hurt anything. It's not going to hurt you, but it lets you work on that one independently. And then when you're done, you go back, turn it back on, and check to make sure that everything's working. So we've got level 2 or zone 2 cables are orange and blue, and then level 3, zone 3 are orange and white. So you'll see different colored cables underneath, but these are not so much anything you really need to know for basic service. This is more, when you are doing a component replacement or replacing a cable, this will indicate to you which zone that those cables are part of, so that when you do your isolation or your disconnect, you know that all cables with white striping are also disconnected. And it's kind of just an easy way to look at it and say, okay, this is what's live and this is what isn't. So the simple way to put it is you've got a level 1, which is sort of your base level disconnect. You've got your level 2 and level 3, and it just grows from there. So a level 1 is a small disconnect. You're not doing too much. You're kind of working on one part. Everything else can stay live. It's not a problem. And then it progresses higher depending on what components you're going to be working on. So we have different ways to do that, or different places to do that. One part of that is the high voltage battery switch in the side electrical panel. That is something that will need to be accessible to be able to activate and deactivate the high voltage system. We've got these big orange disconnects here on the side of the S box, which I'll show you in a bit. And you basically pull those out, and it's just a giant fuse that does not allow power to flow. Let's see here. So we've got also disconnects on the frame rail for different battery strings, depending on where you're working. And then we've also got disconnects on the actual batteries themselves also. So this just sort of gives you a high level overview of, what the zones are or what is in a specific zone, depending on what you're working on. The nice thing about this is when you get into the service manual, if you're the person that's working on one of these, is it's going to tell you what isolation level you need to perform. It's not a guess on your part of, well, I think I need to disable this. It's going to tell you before you do anything, you're going to perform a level 2 isolation. This is how you do it. This is where you do it. And then you're going to perform a live dead live test, which is basically using your multimeter to say, we're going to use a known component that's working to prove that the meter is reading. Then you're going to check on a component that should be disconnected. And then just to be sure, you're going to go back to that component that was working and check again to make sure that your meter detects that. And it sort of is just a way they call it live dead live, or LDL. And that is to say, it was working. We made sure the meter actually reads. And then we confirm that the part was disconnected, and then we also confirmed the meter still works, so we know that middle part is okay as it should be. Again, I'm not going to go through all the zones in particular or levels, but that's the idea behind it. So I pointed out the disconnects to you, a couple slides ago, so I won't go through that too much. Again, you've got a 12-volt switch in your battery box here that is exactly what it sounds like. And then you've got a high voltage disconnect here as well. So let's see here. So without getting too far into some of this stuff, we've got these level 1 MSDs, or manual service disconnects, on the S box. You basically pull the black latch down and pull it straight out. And that is what's going to interrupt power flow and prevent anything from kind of flowing through that S box. So you'll see here some of the striped cables indicating that these are part of the level 2 disconnect. And then these orange here are part of the level 1 disconnect. And you'll see that underneath these buses as you start looking around. We have also level 2 manual service disconnects up front. So these would actually disconnect battery string 1 and battery string 2. They are above the axle, and the same idea. You pull the latch down and pull down, and they pop out of there. more disconnects here, depending on your battery configuration. If you go with the 3-string, farther range battery pack, you're going to add extra disconnects along the way because you've added now 3 more batteries as well to accomplish that additional range. So just to give you a look here at what the battery fuse sort of looks like, there's 8 screws in there that hold that in place. So it's not something that's just going to pop out or fall out. It's mounted pretty securely in there. There's of course a weather seal around it to keep things dry. Don't put your finger in the socket. It's still live. The battery still has power, deep in there. You just can't flow that power now. So some of it's common sense and some of it is, it's just new and we have to learn it. So this gives you an idea here of, you may have power still over here, but it can't flow to this side now. So again, you won't be sticking your fingers in here. And typically while you're working on these, there's actually a cover that would go on this to prevent somebody from accidentally, reaching in there or, swinging a tool around and making contact with something. So just kind of showing you where those are. They're at the very front of every battery pack. And this particular bus would have, a number of battery packs in it because this is a 3-string configuration. So this kind of shows you, what the setup is. The batteries are tucked between the frame rails up high. And the idea with that is really just to protect them and keep them out of harm's way if you were in an accident or, went off the road, whatever it might be. Your standard setup is going to be this front pack, the second pack, and this third pack. So you'll have these 3 on every bus all the time, and that's your standard battery system. Once you get that additional range, or you want to add that additional range, they add 3 more battery packs. So they tuck 2 in right here, and then they tuck 1 more in behind the rear axle. And you can see why your wheelbase and your body size starts to matter, because eventually, if your bus is too short, you're not going to be able to fit these additional packs in up front here. So just kind of give you an idea of how that's set up. And there's 2 stacked on top of each other as well. So kind of a little confusing, but if we're looking at the front of the bus here, you've got string 1 is the one closest to the floor. String 2 is the one closest to the ground. So we're referring to a string as a series of 3 batteries together. So string 1 is these 3 batteries closest to the floor. String 2 is these 3 closest to the ground. And then just to confuse people, they count them backwards from the back of the bus: pack 1, pack 2, and pack 3. So you may see documentation that says string 1, pack 2 is the center battery pack, and that's all they're referring to. When it comes to the additional capacity option, you've still got your standard, 2-string configuration, the exact same thing as above. But once you add that 3rd string, it sort of, it adds 3 more batteries and it changes the kind of configuration just a little bit. So again, just to show you power flow here, the way this works, I'm not going to go through it line by line. Just give you an idea. It's sort of a series circuit, if you will. Power flows from one to the next. There are low voltage cables as well. And these low voltage cables are sort of your tattletales that are reporting back and saying, is this system doing what it's supposed to? Is it charging properly? Is it discharging properly? And sort of reports back and tells the ECM, all is well, or we have a problem. So you've always got to have tattletales in place to, make sure the system is doing what it's supposed to do. As we get into the 3-string, again, it gets a little more complicated, but more or less it's all the same. You're just running cables a little bit farther away. That's all. So same thing with your tattletale cables there, your low voltage, kind of just, again, reporting on the system. So for a few different reasons, you've got battery shields located at the front, and behind those shields is where you find those disconnects. And the idea here is just basically to protect all your connectors and whatnot from road debris. Again, if you're in an accident, it just kind of prevents those things from being at risk of being hit or removed or pulled out, whatever it might be. So kind of, this is a lot to look at, but more or less, this is going to show you the way that the system is wired in or plumbed in, if you will, and kind of show you the flow of power. I'm not going to go through this item by item for the sake of time. We're already 45 minutes into the meeting here. But when you get into actually learning about these, when we come out to your location and we do the training that you would need, you'll get this information. So with that said, we're also doing HV1, HV2, HV3 training. So sort of driver training and staff training, training for you guys and what you need to know. And then there's a level 3 training or HV3 training that kind of talks more to what our guys need to know. But we want to give you some of that information anyway, so that you understand, sort of what you touch and what we touch, and kind of draw that line there. So this S box here, we call it an S box, but really it's a supervisory box. And this is just kind of your relay center for sending power to all the different places that it needs to go. And I have a better visual here. So we've got our batteries here. We've got our manual service disconnects that's going to feed through the S box or supervisory box into a high voltage distribution module. And then from there, it can go 2 different places. One would be right out to the traction power inverter module, which feeds your drive motor, or it can go under the hood and do your high voltage distribution unit, which you can see sort of handles everything else. It's your 12 volt batteries, or what we would sort of equate to an alternator. It would go to that, your cabin heating, your inverters for air compressor, for power steering, all of that other stuff is sort of fed from this HVDU, as they call it. So that's a simplified version of basic high voltage power flow. So I always forget that I do that, and I talk through the whole thing. So you've also got, again, DC to DC converters. They call it DC 1 and 2. And that's a fancy way of saying these are charging your 12 volt batteries. One converter for one battery, the second converter for another battery. And again, it's acting as, or they are acting as, an alternator to keep your 12 volt system fully charged. So just kind of give you an idea of what one of those might look like. There's, of course, a high voltage cable on there. You've got, a bunch of different cables running to different places, but more or less it's for power flow, grounding, and monitoring of that system. So you've got coolant hoses as well that run into these converters because they do get very hot. You're running high voltage into them and converting it. So we need to be able to cool that system. And it's all, again, it all ties back to sort of thermal management and how important that is. So again, just a very quick view of sort of how the power is sent out. So we've got the high voltage distribution unit, as you can see here under the hood, goes into these converters and then out to the batteries. So I showed you the battery packs already and where they're located. We've got our drive motor in the back here. So they take your rear axle and they flip it backwards so that it's driven from the rear, kind of like a rear engine transit style bus. We've got our traction power inverter module, which is just before the drive motor. We've got our S box and high voltage distribution module just ahead of the axle here. All of our disconnects, of course. We have our battery thermal management system. And our air tanks are up front. And then on the battery box side, by the sort of by the driver, you've got your air compressor as well. So it's a high voltage air compressor. Beyond the compressor itself, the air system is identical. It's all the same valves. It's all the same brake parts, all the same part numbers. All the plumbing is identical. So you don't need to relearn your brake system. It just gives it air in a slightly different way. We've got our converters here, 2-in-1 converters, and then we've got onboard chargers as well. So again, without getting too detailed on some of this stuff. So we talked about the battery packs, we talked about the inverter module. There is an auxiliary heater in some places. We can't do that here in New York State because of some of the regulations, but that is the ironic fuel-fired heater to keep the bus warm. We're not doing that here. DC to DC converters under the battery box or near the battery box, 2-in-1 inverter. And let's see here, what else? High voltage power steering, high voltage distribution, distribution module. So there's a distribution module and then a distribution unit. They are 2 different things and they do 2 different things. Very easy to confuse them. We've got our S box that I showed you, and then traction power inverter module, which again is basically delivering power to the drive motor. So your battery thermal management, again, without going too far into detail, its simple goal is maintain battery temperature. Keep them cool, keep them warm, whatever it might be. So we talked a little bit about this already, but this is also feeding your power steering and your air compressor and any cabin heating you might have. So it's got an important job. Let's see here. So I'm going to kind of breeze through some of this stuff here. So our coolant replacement on this system is 60 months or 150,000 miles. You're going to hit 60 months most likely before you hit 150,000 miles. You can use your same Navistar coolant fill tool that you have now, or any pressurized coolant fill tool will work and do the job just the same. And these are the different components that are cooled. So your charging interfaces, your converters, your inverter module, the drive motor, all of that sort of stuff. Let's see here. So again, just some images. I'm not going to spend time showing you pictures. As we do more detailed training, you'll get into that stuff. So we do have surge tanks for cabin heat and for power electronics heating and cooling as well. And then we get to the drive motor itself. So this is a 6-phase motor, weight 470 pounds. You know, it's quite heavy, but it's a 6-phase motor. And the important thing about a 6-phase motor is smoothness of operation. So here you're looking at the traction power inverter module, and you can see one cable for each phase being fed into the drive motor itself. The idea behind the phases is, rather than having very severe rise and fall of voltage, as you add additional phases, what it does is it kind of shortens the distance between these peaks here. So we go from a very large distance with a drop in power to now very short distances between drops in power, which is designed to make a smoother operation generally. So I touched on the air brake system. Your air tanks, air valves, all of that is exactly the same. What you'll notice is different is that we have 2 separate tanks as opposed to one single unit, which is what we've seen for the last few years on the IC bus. I'm not sure why they changed that or if they'll change it again, but that's what we've got now. So your high voltage air compressor, it's exactly what it sounds like. It uses high voltage power to pump air and pressurize your system. It still uses a governor, still uses a filter. Normally you would use on a Cummins engine, your air intake filter does your filtering for the air compressor. In this case, we've got a separate air compressor intake filter, which gets replaced every 10,000 miles, 400 hours, or once a year. Don't get hung up on the mileage interval. It's probably going to be, once a year. Over the summer, you might replace that cartridge in there. So let's see here. So we still have a governor. The kind of interesting thing is we are using a mechanical governor still that we're used to. It's the D2 style. They do now have an additional electronic control added to it. So if you get into the electric truck version of what we have, the governor is fully electronic. And in our world, it's still mechanical with a side of electronic there. And I think that's probably just a DOT thing, federal for backup in the event that there's a problem with the electrical system. So let's see here. What else? High voltage power steering is, again, exactly as it sounds. We are just using a high voltage system to pressurize the power steering fluid and allow us to turn the wheel freely. So power steering fluid and filter every 2 years on the electric bus. I'm not going to go through all of this. This is a simplified way to show you and say that the bus still uses, J1939 protocol, still uses data links, still uses a 9-pin connector. All of that stuff stays the same. It's just broken up a little bit differently than you would see on a diesel bus or gas bus. So HVAC, I'm not going to go too far into either. You can get air conditioning on these. Obviously, you can have heat. The way they're set up is a little bit different than what we're used to, but more or less it does all the same stuff. We've got a bunch of different components here that might look different. We have a high voltage AC compressor now because we don't have an engine to power the compressor. We need to have a high voltage version of that. We've also got an inverter module for power transfer and that sort of thing. So, if we get into a point where we have these out there with air conditioning, we'll go into this in more detail. Let's see here. So second to last slide, just giving you an overview under the hood. You've got your power electronics surge tank here. your cabin heater surge tank. You've got your 2-in-1 inverter. We talked about the high voltage distribution unit and what that does: power steering, air compressor, converters, cabin heat, and so on. You've also got a supervisory control unit, which is just another term for an ECM, basically, or something that's controlling something else, next to the actual ECM, which does exactly what an ECM does. It monitors the system, tells it what to do, responds to inputs, and provides outputs. And then lastly, under the hood is your high voltage power steering pump. So it's a fairly clean setup. Again, you're not going to get into much of the teardown of these parts in your shops, but I think it's still good to understand what they are and what they do. So lastly is your warranty. This is standard stuff. You can go up on any of these like you can with any warranty. 5 years, 100,000 miles on the charger, cables, inverters, all of that sort of usual stuff related to charging. 5 years, 100,000 standard, you can go up. The power steering pump, air compressor, 1 year, unlimited mileage. Again, there's different options for that. Standard chassis warranty. Batteries are rated for 8 years, 175,000 miles. Drive motor is 5 years, 100,000. In the beginning, I mentioned vehicle to grid and why I don't recommend that. Right now, the IC bus does not have a warranty on what they call battery throughput. Throughput is basically total accumulating all the power taken out and all the power put back in, and it just adds that together over time. And with a throughput warranty, what can happen is, if you're doing vehicle to grid where the utility company is coming in and they are pulling power out of your batteries that you don't need, and then at night feeding it back in, that counts as throughput. Even though you're not using the bus, it's not moving, not being touched. All day, every day in the summer, they're taking power out, they're putting power back in, taking power out, putting it in, and that is counting against your throughput warranty. I say that, we don't have that warranty yet. We will have a throughput warranty. Others do. We're getting there. We're still going to have that. And that's you could blow through that really quickly by doing vehicle to grid and not have much of a warranty left, after, 5 or 6 years. And then that's on you at that point, which nobody likes. So all that said, that is, like I said, my very quick overview of the electric bus. Happy to take questions at this point and keep going.
Hey, I got a question.
Sure.
I got a mixed fleet. I got 60 Thomas little buses. I got 160 the international big buses.
Yep.
Now the dealer doesn't spec the charger, right? Can I get a charger that's going to work on both buses? That's my question.
Theoretically, yeah. All of the ends are the same. It's like a USB port is a USB port. It's kind of the same idea. They all use a CCS1 type charger. The problem could be in the software that charger has to use. For the most part, they're pretty agnostic, and you can plug in whatever you want as long as it's, let's say you have a series of VINs programmed in. As long as that VIN belongs to you, yeah, it'll charge it. If somebody shows up with their Tesla and plugs in, you don't want it to charge their car. So the software could be made to allow certain things or not allow others. That's not something that we're really going to run into much, but you can have a mixed fleet. You can charge everything, and it's not going to be like you need to have a different charger for your Thomas than you do your IC, than you do your Bluebird. It's all park wherever you want, plug into whatever you want. It doesn't matter.
Well, on top of that, I got another 50 maintenance vehicles. You know what I mean? I'm talking Fords, Internationals, Chevys.
Yep.
That I'm going to have to charge them. I'm going to have to work on them in my shop. I'm going to have to be able to charge them in the shop. I don't want to have like 50 different damn chargers I got to have. Right?
Yeah, that's not going to be an issue. And especially as these become more prominent out there, they're only going to further make sure that every charger is the same for everything. Just like you go to the gas pump and they're all the same thing. They have to be. We can't differentiate vehicle to vehicle. That just doesn't make sense. So good question though. Anything else?
Hey, Kodie, you were talking about the regenerative braking.
Yep.
And you said when it reaches 100% batteries, like if you just leave in the morning, the regenerative braking will still slow the bus down, right? It just won't store any power.
No, it can't work at that point.
Okay, so it just doesn't work at all.
It's like having your exhaust brake turned off.
Mm-hmm.
You just use your brakes as normal at that point. And I believe, I don't know the number off the top of my head, but I think it's something like above 90% or 95%, it won't regen brake, somewhere in there. And at that point, you hit 89%, let's say, and then it'll start to work. But, again, you're going to get to a point where you potentially get over that 90 hump again, and then it stops. So there's going to be a weird point in the early part of your run where it doesn't work all the time because it doesn't need to, if that makes sense.
Okay.
Well,
Other questions?
That's going to be really noticeable for their driver, isn't it? I haven't driven an electric bus. Don't care if I ever get to. No offense to anybody, but I'm hoping to be out before all this hits here.
Yep.
But won't that be like a huge difference in that what that driver's feeling between regenerative and the non-regenerative?
I don't think so. I mean, especially now, like you've got in your fleet, for example, you've got a ton of gas buses without exhaust brakes on them. It's just like stopping one of those. There's really no difference. And really, you don't even need to use the regen braking. We have the ability on the panel to shut it off completely. And you may have some drivers that do that because we know we have people that don't like the exhaust brake. They turn it off because they don't like this or that about it. That's the same thing. There's a benefit to using it, and you will notice a difference with it on for sure. But otherwise, it's just like stopping any other vehicle. You just have less assistance from the drive motor, basically. Okay. All right. Any other questions?
When you spoke about the charge cord, I know like on other vehicles and stuff, there's an auto disconnect just so that you can't pull away with it.
Yeah.
Is that something that you guys have built in?
Yep. So if the bus is plugged in, you cannot, quote, start the bus. It won't allow you to do that. For that reason, we don't want somebody driving off and pulling a $50,000 charging station down the street with them. Wouldn't be received very well. So
yeah, that's what I was thinking.
You will disconnect. And the other thing too, kind of to add to that, is when the bus is done charging, it's going to stop charging on its own. That charge cable might still be plugged in, but it might not actually be charging. So the system is pretty intelligently designed to, sort of idiot proof it as much as possible, if you will. So if you guys have other questions that pop up, bus related, let us know, of course. As far as the planning part of this right now, the bus is the simplest part. Forget about it. You've got to figure out how to charge, how to get enough power, how you're going to pay for it, what upgrades are going to be needed. Those conversations are definitely happening now. So, don't shy away from it too much. As of right now, 2027, everything we purchase that's DOT'd has to be electric. By 2035, you can't have any combustion engines in your DOT school fleet. So seems easy to ignore, seems more comfortable to ignore. We're, as dealers, I think, and I shouldn't speak for all of us, but at least from conversations I've had, we all feel kind of the same way, that we recognize that this is probably not the best move on the part of New York State, but we're going to do our best to get through it and make sense of it as much as we can. With what information we have.
I don't think anybody's ignoring it, but the problem is we can't get the damn power. I mean, right now, they can tell me I got to buy a bus, and I buy buses.
Yeah.
But I can't plug them in. And when I do plug them in, I can't get enough power to the amount of power for 220 buses. The wires aren't big enough. The guy even told me I can't make a wire big enough to put that through to you.
And that's the problem, is like I said, we can order you a bus and deliver it, and great, awesome. You can't do anything with it. You need to be able to charge, and different fleets are going to have different levels of difficulty. You're a 217 bus fleet. That's a lot of power. I mean, that's the power. That's enough power to run a small town, you know. Whereas
That's the equivalent. Just so you know, that's the equivalent of the Empire State Building every day
right
for
and
the
it's huge.
buses, just the buses.
Right. And that's an insane amount of power. And I was at a district last week. They have 8 buses total. You know, they're in a different kind of situation with it. They're a very small district with not a lot of money. And yeah, they can power their 8 buses, but you know, they're a small operation. All of their kids, superintendent, everything are contained within one building. You know, they're not in a financial position to add a charger, you know, let alone a district that needs to add 200 chargers. It's just that this is the hard part of it is all of the charging, the infrastructure, the getting ready part. Hopefully, once we're through all of this over the next few years and we have our chargers in and our facilities are up to date as they need to be, as much as they can be, it's going to be a matter of we order the bus, we deliver it, you plug it in, and that's it. And it's not this constant talk of, you know, chargers and infrastructure. That'll go away eventually. You know, right now we're starting from scratch, basically, is how I look at it. Okay.
All right. Does anybody have any other questions for Kodie? If not, I want to say thank you, Kodie, for your presentation.
You got it.
And you're always really informative. I'm glad we were able to record this. This is a very good lot of information here. Moving on, our next meeting will be held on December 14th. New York Bus Sales will be presenting on the Bluebird electric bus. So, like we're saying, this is kind of being forced on us with these electric buses. So we want to get as much training in as we can. But again, that will be on December 14th. The last thing that I have is our Christmas party. At this time, we are going to cancel the Christmas party. There's not enough school districts that are interested in attending the Christmas party. It's not just my decision. We have a steering committee that consists of, I think, Leonard, Matthews, New York Bus Sales. A few of the districts are also members. And it's just that we don't have enough people from the school districts that are interested in having a Christmas party. So at this moment, we are going to cancel the Christmas party. We're going to try to do something over the summer to take its place, maybe a clam bake or something. So when the weather breaks, we'll get together then and do something. I will follow this up with an email so that everybody knows. Does anybody have anything else to add to today's meeting?
Hey, I just want to say I know I sound negative. And I'm not really negative. I'm the kind of person we'll do, and the guys here will do whatever we got to do. And I'm sure all you people that are involved will do whatever you got to do. And we got the state telling us what we have to do, and that's fine. I think they went about it wrong, and they're handcuffing us. But as industry wide, everybody seems to pull together and do what they have to do. Vendors, school districts, everybody. It's just sometimes the mountain seems like high. And right now this one seems high because even though we're trying to do exactly what we got to do, in order to turn over my fleet, I got to turn over in 10 years. I got to get 22 buses a year. And the price of a big bus is going, say, from 120 to 400,000. So that's a big thing. And then you got to add the power. Well, in order to add enough power, it's got to be a bond issue. It isn't just like George and Al can say, we got to go out there and add this power. We can't. The price is to do it fiduciary way, legally, it's got to be a bond issue. And it can't be a bond issue 1 year. It's got to be a bond issue and another bond issue and another bond issue. And it's just, people don't know what we're really up against. And that's a big district. And the little districts, again, hats off to the little districts, because I don't know how you do it every day. We have more resources and we have more people that we can throw at problems than a little district does, where you have one guy that's doing everything. I mean, hats off to the little districts. I don't see how you do it. And it just amazes me every day what the people can actually pull together and do. And I just want to say thanks to all the people that are out there doing that right now. And again, I'm not trying to be negative, and I hope I don't come across as that negative. I just don't know how to do it. I started out pumping fuel as a kid and worked my way up through. And a lot of you guys are the same way. And now it's another big, huge change. Do I hire a mechanic or do I hire an electrician? I have no clue. And where do I get the training for it? Don't know. Working on that too, amongst all the other problems. And again, hats off to all the school districts and all the vendors, because they're going to have to pull together to get this done. Thank you.
Yeah, the nice thing is, we're not alone. We're all doing this together, and we will figure it out. We have to. But does anybody have anything else to add to today's meeting? I know I've kept you guys long enough. So does anybody have anything at all? Okay, at this time, I'm going to close the meeting. But just to recap, the Christmas party is canceled. We cannot do it.
How about thank you for your efforts at trying to put this Christmas party together. I know you've spent a lot of time personally. You've sent a lot of emails out, and the other people that have worked together on this Christmas party too. Thank you for your efforts. I appreciate it personally. Thank you.
Well, that means an awful lot. I do. I appreciate it. Thank you. All right. I will see everybody December 14th. New York Bus Sales, Bluebird Buses.
Thanks, Danny.
No problem. We'll see you later.
You got it. Have a great holiday.
You too.